Hi, Algebra 2. These are the homework answers for Lesson 11-3. You should have already watched the video and tried these on your own. If you haven't done that, please watch the video that Mr. Cornell made for Lesson 11-3, exact values, and then try these problems and then check your homework. So basically what's happening in question 1 is you're filling in the table to find the sine, cosine, and tangent of 30, 45, and 60 degrees. Back when we did these in geometry, I mean, sine of 30 is a half, so that's exact. But when I did sine of 45 in my calculator, we got 0.7071, and it kept going on and on. This time I want to find the exact value. Those exact values come from these special right triangles, so it is important that you know these special right triangles. If I have a 30, 60, 90 triangle right here, the side across from the 30 is 1. The side across from the hypotenuse, the side across from the right angle, the hypotenuse, is twice that, 2. And the side across from the 60 is 1 radical 3, but I just write radical 3. In the 45, 45, 90 triangle, the legs are both 1, and then you could always use the Pythagorean theorem to figure out this hypotenuse, but it's going to be radical 2. So again, in 45, 45, 90, the legs are both the same, and the hypotenuse is that same number 1, but radical 2. So it's going to be radical 2. I drew this equilateral triangle up here just so you can see that the rule for the 30, 60, 90 actually comes from taking an equilateral triangle and splitting it right down the middle. Okay, if all the sides were 2 in this equilateral triangle, all the sides were 2, the angles are all 60. If I drew the height, the altitude, it cuts this length of 2 in half, so this is 1. It also cuts the angle in half, so the 60-degree angle is now 30 degrees. The side across from the 30 is 1. The hypotenuse is 2, and then if I went to use my Pythagorean theorem to find the missing altitude, which is also the side across from the 60, I would get radical 3. So you really just need to memorize these 30, 60, 90, and 45, 45, 90 triangles. So sine of 30 degrees, go to 30. Sine is opposite over hypotenuse, 1/2. Sine of 45 degrees, go to 45. Here's my 45. Sine is opposite, which is 1, over hypotenuse, which is radical 2. Now, I don't want to leave a radical in the denominator, so my answer is 1 over radical 2. I multiply the top and the bottom by radical 2. So my numerator becomes 1 radical 2, or just radical 2, and my denominator, radical 2 times radical 2, is radical 4, which is 2. Sine of 60, go to the 60 degrees. Sine is opposite over hypotenuse, radical 3 over 2. Cosine of 30, so now cosine is adjacent over hypotenuse, radical 3 over 2. Cosine of 45 is adjacent over hypotenuse, 1 over radical 2, but again, I have to rationalize that denominator, and that becomes radical 2 over 2. And then cosine of 60 is adjacent over hypotenuse, 1/2. Tangent of 30 degrees. Tangent is opposite over adjacent, 1 over radical 3, but I rationalize the denominator. I multiply numerator and denominator by radical 3 over radical 3. So that becomes radical 3 in the numerator and 3 in the denominator. 45, tangent of 45 is opposite over adjacent. 1 over 1 is just 1. And tangent of 60 is opposite over adjacent, radical 3 over 1, and I can just write radical 3. 2 is just a multiple choice question. You can really just look at the right triangles, the special right triangles, or look up in the table I just did up here. Sine of 60 degrees is radical 3 over 2. 3, I'm making it a little bit more complicated because I'm going to do multiple of these special right triangles. Sine of 60 is radical 3 over 2 over tangent of 30. Notice this is saying find the exact value, so you cannot do this in your calculator. Your calculator, well, actually, you probably could do in your calculator because my answer does come out to 3/2. Those radicals will cancel each other out. But sine of 60 is radical 3 over 2. Tangent of 30, look in the chart up here, is radical 3 over 3. When I divide, I change to multiplication and I flip this second fraction. So that's going to become 3 over radical 3, and the radical 3's cancel, and I'm left with just 3/2. Sine of 45, looking at my chart right here, is radical 2 over 2. Cosine of 45 is radical 2 over 2. And tangent of 45 is 1. So I'm just multiplying all these. The 1 will do absolutely nothing. You can just disregard that. When I multiply by 1, the answer stays the same. Radical 2 times radical 2 is radical 4. And 2 times 2 is 4. Radical 4 equals 2. And 2/4 can simplify to 1/2. 4, you have to draw your own picture. So cosine of theta is 6 over 7. So I draw a right triangle. I put theta down here. Cosine is adjacent over hypotenuse. The 6 is adjacent, so I put the 6 right here next to theta. The hypotenuse is the bottom number, so 7 is the hypotenuse. I put my hypotenuse here. I then use my Pythagorean theorem to find this missing side. So x squared plus 6 squared equals 7 squared. X squared plus 36 equals 49. X squared equals 13. All I did was subtract 36. X equals the square root of 13. So now I know this missing side is radical 13. And I can find all of the other 5 trig ratios. And again, I'm finding it in simplest radical form. Sine is opposite over hypotenuse, so it's radical 13 over 7. Cosine is adjacent over hypotenuse. That one I already had, so technically I didn't need to find that again. Tangent is opposite over adjacent, so it's radical 13 over 6. Cosecant is the inverse of sine, so I just flip this and I get 7 over radical 13. But then I multiply the top by radical 13 and the bottom by radical 13 to rationalize the denominator. So I get 7 radical 13 on top, and radical 13 times radical 13 is radical 169, which equals 13. Secant is just taking cosine and doing the inverse, so it's going to be 7 over 6. And cotangent is taking tangent and doing the inverse, so it's going to be 6 over radical 13. Again, I'm multiplying top and bottom by radical 13, so I get 6 radical 13, and on the bottom I have radical 13 times radical 13, which is radical 169, which is 13. To change degrees to radians, I multiply by pi over 180. That's on your reference sheet for the regions, so that will be on a reference sheet that you can use for any test or quiz. And I just canceled, so I cancel the zeros. That's really just dividing by 10. And then I notice that both of these are divisible by 3. 33 divided by 3 is 11, and 18 divided by 3 is 6. So it's 11 pi over 6. 6 is a problem we actually did last year back in geometry. So I have the sine of x plus 30 equals the cosine of 2x plus 80, and they want me to find the value of x. The rule is the sine of a equals the cosine of b if and only if a plus b equals 90. This is my a. X plus 30 is my a. 2x plus 80 is my b. Those equal 90. So I'm going to take x plus 30 and 2x plus 80 and set it equal to 90 and solve. Combine those x's, I get 3x. 30 plus 80 is 110. I subtract 110 and I get negative 20. And I divide by 3. X is negative 20 over 3. Okay, and those were the answers for the lesson 3 homework.